Hi all, this is just a little bit of extra information about section 1.3 in terms of finding equations of both lines and also planes. Okay, so when we talk about finding the equation of a plane, of course, we are looking in R3. Okay, because if we're in R2, then our whole field of study is just R2 or the whole coordinate plane. But there are infinite amount of planes if you're thinking about being in R3 or in space. Okay, so if I want the vector form of equation of a plane, what we need to make sure you remember is that you need to have two direction vectors. Okay, because a plane doesn't just have length, but it has length and width. So if you think about, like we talked about in the PowerPoint slides, we know 2 points determine a line, but you need 3 points to determine a plane, and non-collinear points, that is, because you'll have a line like this passing through R and S, and a line passing through S and T like this, and then we uniquely define a plane. Okay, so you can actually find any of the direction vectors with the 3 points. I chose to find RS and RT. Okay, but you could have also found vector ST as well. Okay, but anyway, if we take those, of course, we can just subtract the components of the vectors in order to actually find that vector RS is 3 minus 2, 1, 2 minus 0, 2, and 1 minus 6, negative 5. Okay, so there's one direction vector for the plane, and there is a second doing the same work. Okay, so vector form is really easy. Just instead of xy, it's xyz is equal to now any vector whose head is on that plane. So it's really any of these 3 points can be represented right here, but then the two direction vectors, so you need the two parameters s and t. And how this works is that this equation right here could generate all points on the plane. You just go through all scalar numbers for s and t. In other words, if you make s 0 and t 1, okay, then you could actually find the point t, which is 1, 5, 1. Okay, and of course that point would be on the plane in question. Okay, so for the normal form of the equation of a plane, okay, I showed you this one already on the PowerPoints, but it's just written out a little bit neater here. Okay, the key here is that we still need the norm to the plane. Okay, so if you don't have a norm, literally just represent it as the norm is A, B, C. Okay, and then we can use our dot product, knowing that the norm has to be perpendicular to any direction vector to the plane. So I use these two direction vectors. Okay, and then solved. We could have made B 1 and then C would have been 7/10, but so as not to deal with fractions, that's why I made B 10. Then C, of course, would be 7. Plug it back in, you find A is 15. Okay, and then of course once you have the normal form, it's really nice because right here you can also get standard form for the equation of the plane. Okay, so there is an easier way to find a normal for a plane given two direction vectors, which is called the cross product, but we're going to talk about that later. Okay? And then last but not least, we did this in the PowerPoint, but I just wanted to also present this to you again and give you a little more detail about finding the equation of a line in R3. Okay, the difference between R2 and R3 obviously is R3 has the three components, so that's why we need an X, Y, Z. Okay, but what we need to make sure of is that if we're doing vector form, we know we can find a direction vector easily, just given 2 points. Okay, and so we found vector PQ and we're done. Okay, so vector form is extremely easy even if we're still in R3. But when we go to normal form for this very same line, okay, we need two norms. Okay, and we've discussed that a bit, but I will discuss it further again for you. Okay, so instead of just writing norm equals ABC, when I'm trying to find normal form of a line in R3, those three pieces, then I'm going to have to say norm 1 is A1, B1, C1, norm 2, A2, B2, C2. And I'm going to have to literally make it a puzzle. Okay, seriously. We just know that we're going to have A1 plus 0 minus 3A C1 is equal to 0. Okay, and same thing over here, but just make sure when you can put in values now, anything you want. for C1, then you can, or A1 for that matter, and you can solve for the other. Okay, but the key here is these two norms cannot be parallel to each other or multiples of each other. So I couldn't say 6, 0, 2, just multiplying each of these by 2. So easy enough for this one, since I have a 0 component, I can just put in any value here. So 6, 2, 2 is okay. Okay, now what I want you to do, of course, is understand that you then just take both the normals and do what we know to do for n dot x equals n dot p, and then n dot x equals n dot p for the second normal vector. And we come up with the two equations that will actually represent one line in R3. And think back to class last Wednesday. This with this gives us two planes, really, and the intersection of two planes is a line, okay, in R3. So hopefully that helps, and I know it takes a little bit of practice, okay, but what you have due for me on Wednesday is really just in R2, so it makes it a lot easier to get that practice in. Okay, good luck with everything. Email me, come see me. I'll be happy to help.